Good day again. Welcome to another episode by M.I.B. Math is Beautiful. And today we'll be looking at the sigma notation. Now, instead of writing out a series in full with each term, we generally use the sigma or the summation sign to actually write out or sum the general terms of a series. Let us consider this sequence here. 1, 7, 13, 19, 25. Goes on to infinity. Now the series of this sequence will actually be 1 plus 7 plus 13 plus 19 plus 25 goes on to infinity. Now one could not possibly write out all these terms. So what you'll do is just basically find the general formula of this series and then incorporate the sigma notation to give a more general summation, a general notation of the summation of the series. Now this series here, the formula can be found by looking at whether it's an AP or GP, which was summarized or discussed in the previous tutorial. So we look at this, we can see that it's an AP with a common difference of 6, right? Now the general or the nth term of this would indeed be an is equals to 6n minus 5, right? Now this would be the general formula of this series. Now in terms of adding this series from the first term to infinity, we can incorporate the summation sign to mean that we should sum the general formula 6n minus 5. However, we have to put in the limits. This is saying that we are summing from the first term, that is when n is equals to 1. So at the bottom of the sigma notation, you put n equals 1, stating that at this point, this is where n should start. Because what if it was a series where the first term was 19, right? In our case, then you would actually sum from n equals 4. So again, if we're summing from n equals 1, we would put n equal 1 at the bottom of the summation sign. What if we were summing from n equals 1 to n equals 5? Sorry, from n equals 3 to n equals 5. Then at the bottom of the summation, we would actually have n equals 3. Now at the top of the note of the summation indicates the extreme to where we are summing. The range, the extreme range of which we are summing in the series. And in this case, we are going up to infinity, right? So we are saying that we are summing from n equals 1 to infinity of the function 6n minus 5. And this would actually be this series, 1 plus 7 plus 13 goes all the way to infinity, right? Now, what if we had this series 1 plus 7 plus 13 to 25, right? Then in this case, we'd be summing from, let's just say we are summing from from the first term to 25. Then 25 would indeed be the 1, 2, 3, 4, fifth term. So it'd be summing from n equals 1 to n equals 5 of 6n minus 5, right? Now let us look at some rules for manipulating sums, right? Now we call these rules for manipulating sum. Now one of the first rules that we're going to look at is that with the summation sign, the sum of AR, where R starts to 1 and goes to n, plus the sum where R starts to 1 and goes to n of BR, this is equals to the sum of R equals 1 goes to n of AR plus BR, right? So from this we see that once you're summing two functions, right, and you're adding those two functions, right, and they are going along and you're summing them along the same ranges from R equals 1 to n, as you can see, then it indeed you can actually sum those equations independently, or add those equations independently, simplify them, and then apply the sigma notation to those. So indeed, you're starting from r equals 1 to n and summing the independent equations, right? The second formula that we will look at is with respect to a constant. K indicating a constant. So we are summing from r equals 1 to n of AR, multiplying that by a constant. This is also equivalent to if you're summing from r equals 1 to n and multiplying the constant by the function. So this is equivalent to summing, multiplying both and applying the sigma notation as well. Next, another that we look at is with respect to the summation of a constant only. So from r equals 1 to k. Now this is the same thing as n times k. So what if you're just looking at a constant? The constant is the number 1, right? And 1 goes on. Well, actually this should be 1 plus 1, sorry. There should be a plus here to denote a series. Now, a constant k. Now, if you're summing from r equals 1 to the n, let's just say the nth term is actually infinity. Then the summation of this would have been infinity times 1. Hence, infinity times 1. What if you're summing to the 1, 2, 3, 4, 5, 6, 7, the 7th term? Then n is equal to 7. That would be 7 times the constant 1, which is actually equal to 7. Let's just look at this one here. We're summing from r equals 1 to p of AR plus the sum of r equals p plus 1 to n of AR. Now, once we look at this, we see that we're dealing with the same function. However, you are moving from a starting point of where r is equal to 1, which is generally the first term, going to p. And then you want to sum from r equals p plus 1, which is the term after p, going to n of the same function. Then this can be contracted to saying that you're summing from r equals 1 going straight to n of the function, right? So for example, let us just say that you have 1, 2, 3, 4, and again these should be plus 5, plus 6, plus 7. Now this is the function, right? Where 1 is the first term, 2 is the second term, third term, fourth term, fifth term, sixth term, seventh term, respectively. Now, if you're summing from the first term, where r is equals to 1, to r is equals to 4, right, of the function, plus, so you're summing from r equals 1 to 4, right? And then you're summing from r is equals to 4 plus 1, so you're starting at 5 to 7 of the same function. Then this is equivalent to if you are summing from r equals 1 straight to 7 of the same function. Let us look at the standard results of some series, right? Now these are standard results. Now it is really good to actually know these, and I'll just be putting them in a tutorial just for edification purposes. Of course, these can be proved, we can actually prove these, but we'll actually get to that at a later date. Now, for edification purposes, please just note these standard results. So the sum of r equals 1 to n of r is equals to 1 plus 2 plus 3 plus 4 goes straight to n, because you're going from r equals 1 to n. This is equals to n times n plus 1 all over 2. Right? Now, the sum of r equals 1 to n of r squared, and this is equals to 1 plus 4 plus 9 plus 16 plus 25, and plus goes down to n squared. And as can be seen, you're realizing that these are the summation of the perfect squares, right? 1 squared is 1, 2 squared is 2, 3 squared 9, 4 squared 16, so forth, right? This is equals to n plus 1, 2n plus 1 all over 6. Yes. All right. Looking at the third one, the summation of r equals 1 to n of r cubed is equals to 1 plus 8 plus 27 plus 64 plus n cubed, and this is equals to n squared n plus 1 all squared all over 4. Now let us consider this question, which says that we should simplify using the rules of series and sigma, right? Now the question is to simplify the summation of r equals 1 to n of 3r plus 7, right? Now looking at this, we realize that we can actually split this based on the rule. Well, I think that was the first rule that was given. You can actually look back at that, and we can actually split this to two sums. R equals 1 of n of 3r plus r equals 1 to n of 7, right? Now we're looking at the summation of r equals 1 to n of 3r. We can see that this is common to the first standard rule here, which is from r equals 1 to n of r, which is actually n times n plus 1 all over 2. So this is the same thing as taking out the constant, which is actually 3 summation of r equals 1 to n of r plus the summation of r equals 1 to n of 7, right? Now, if we're looking, let us look at the standard result of this series. The standard result of this series is actually n. So this will actually be 3 times n plus 1 over 2 plus, based on the one of the rules before, the summation of r equals 1 to n of a constant is the same as n times the constant, right? So simplifying this is actually equals to 3 times n of n plus 1 over 2 plus 7n. And of course we can move to simplify this further if we want, but of course you can actually do that at your will in terms of turning everything here into a quotient, right? But this is the general format in which we use to simplify sigma notations. Thanks for watching this video. Please like, subscribe, hit the notification bell, leave your comments, and visit us on Facebook at M.I.B. Math is Beautiful.